This is the third in a series of videos in which I'm repairing and restoring a number of Intel MDS systems. If you saw the previous video, you'll know that I went through and resolved, or partly resolved, a problem with this power supply. The 5-volt rail was lower to only 1.1 volts, and that turned out to be the over voltage protection kicking in and the supply going into current limiting mode. And looking at the schematic, I speculated that possibly one of these two diodes were open circuit, simply because when I connected the sense lines, the supply started working. The supply line was a little high, and I wondered at first if maybe we were just on the borderline between these diodes being able to control the voltage low enough to prevent the over voltage threshold being reached. But when I started looking into this and measured between the pins on the output of the power supply, which are these pins on this connector, there was no diode showing across these two pins. There was on this one, but not on this one. So as you can see, what I did is pulled out the front module. So this module is the multi-supply module. The 5-volt module is the one at the back. We'll have a closer look in a minute. And I found the offending diode on the board. Have a quick look. It's quite hard to see, but it's the one at the top left. Don't know how clear this will come out, but it's this device here. But when I measured across it on the board, it measured fine. So it was a bit strange. At the pins it was measuring nothing, and across the device itself it seemed okay. So I assumed there's a break somewhere on the board. So I had to pop the board out. They're quite easy to get out. It's just a case of taking a couple of screws out, as I've done with this one. Some on the top, some on the bottom, and then the entire module will just slide out. Not quite as easy with the one on the back because the wires going to it are very thick, so you do have to unbolt them, but they are luckily, as I say, bolted on, so it's just a case of undoing these connections. And I found something a bit strange in that the diode had never been soldered in. One end was soldered and the other end just had a blob of flux on it. There wasn't any or very little solder on it at all. Now of course it wouldn't have mattered if the power supply had been installed in the machine, but with it out of the machine the diodes are required, otherwise there is no sense feedback. So I resoldered that, checked the other capacitors on the board, on the module, checked everything else, and I've reinstalled it. As you can see, I'll just quickly spin the supply around so you can have a look at the back. Okay, so not a great deal to see on the back. It's just a module similar to the one on the front, just the 3 power devices. So these are the 3 pass transistors, and then you have the 2N3055 and the device at the end. You can just see the back side of that is the SCR, and the rest of the components are on the board that sits on the front of this module. So as I say, to get the board off you have to take the module out, desolder each of the 2 pins on the power devices, take the nuts off, and then you can separate the board from the power devices. So I've done that. I've been cleaning the supply up, I've de-rusted the transformer, cleaned everything else up. Now when I do restorations like this, I tend not to go overboard with the cleaning and polishing. I know some people like to strip these right down, polish them up so they're nice and shiny, but I tend to try and return them to how they would have been originally, and that's not how they were made. So I try to get them back to their original condition. I replace as few parts as possible. On this particular supply I have replaced a few of the screws and fasteners. Some of the old ones were quite corroded, and it wasn't just that they don't look good, but some were grounding screws, and obviously a corroded grounding screw is not going to do very much. However, what I do with each unit is when I return it, I'll return each one with a bag that contains all the original parts. If I've swapped anything, I'll return all the original parts. So if the owner wants to pop the old screws back in for authenticity, then they can of course do that. Okay, so what I'll do now is I'll finish cleaning it, I'll reassemble it, and then we'll start doing a full power test. Okay, so I have the 5-volt rail set up for testing. I've refitted the cooling fan. I will need that of course because I'm going to be running this for quite a long time at full power. I've done most of the cleaning, a few bits here and there to finish off. As I say, I've replaced some of the fittings just either for cosmetic reasons or because they were ground points. I've made up an adapter, so this not only allows me to connect some fairly high current cables to the supply, but it also connects the sense terminals to the supply and return pins as well. I've got this connected to the Kunkin KP184. The test meter is actually connected to this connector, so I don't want to measure it at the electronic load because we'll have quite a lot of drop in these leads. We'll be measuring up to about 24 amps. I won't go up to the full 30 amps here simply because I want to get some more loads and then do full power test with all the supplies connected. And I will be doing this same test on all the individual supplies separately, and then I'll test the entire supply with all the loads connected at the same time. Now the fan is quite noisy, so for the purpose of this video I'm just going to unplug it, but normally I would have it spinning. The supply is a little over designed, so it's not going to overheat very quickly. I just, as I say, I will connect it for the long duration tests. Okay, so we're ready to get started. I've got the electronic load set to constant resistance. We'll start off at 10 ohms, and remember this is a 5-volt supply, so we'll be running initially at about half an amp. And I'll be keeping an eye on all the temperatures and making sure nothing's running away or getting too hot. So to do that I'll be using the thermal camera. Okay, so I'll get the power switched on, and as you can see we're getting 5.08 volts at the connected terminal coming from the supply. At the moment the electronic load is reading pretty much the same, but these will start to diverge as the current increases because of the voltage drop across these leads. This is one of the reasons this particular supply has separate sense return connections, so it can actually monitor the voltage at the target board. Incidentally, the reason I'm going to so much trouble with the power supply, it might seem overkill for just the power supply. This is in some ways the most important part of the test process when you're restoring a piece of equipment like this, because if this fails in a bad way, it can take out every other component in the machine. As I said in the previous video, this is capable of providing a huge amount of current, and there's not many parts of the machine will be able to tolerate that if something goes badly wrong. So it's well worth the time and trouble fully testing the supply, making sure all the over voltage protection works, the current limit works, and all the voltages are correct before you plug this into anything. Okay, so we've got 5 volts. I'll turn on the electronic load. We should be running about half an amp, which we are. The voltage is still at 5.08 volts. I'll now start to adjust the electronic load. We'll bring the resistance down and the current up, so we'll go down now to 5 ohms, which should of course give us 1 amp. And indeed it does, and we're still seeing 5.08 volts on the output. Notice already we're starting to get a discrepancy between the two readings on the electronic load and on the test meter, and this is just at 1 amp even though these are very heavy cables. Okay, so we'll go down to 2 ohms. I'm of course keeping an eye on the current coming from the main supply. you're probably not going to be able to see the reading on the auto transformer. It's not that clear on the camera. Currently it's showing 237 volts at 0.3 amps, and on the electronic load we're up to 2.5 amps, as we should be, a little under 13 watts, and we're still showing 5.08 more or less volts coming from the power supply. Don't worry about the fan not running at these sorts of powers. This would run indefinitely without the fan going, and also of course we're only running and loading one supply. I will just check everything with the thermal camera to make sure nothing's getting hot. I did test incidentally all the large capacitors when I had the modules apart, and they were all fine. I didn't need to replace any at all, but as I say, I will keep an eye on those over the initial running of the power supplies. Okay, so nothing getting hot that shouldn't be. Now, with cheap electronic loads like this, I'd recommend that when you start getting down to very low resistances, that you turn the output off before you make an adjustment. The adjustment's quite good on this particular unit, but it's very easy to overshoot the value you're trying to set. And if you're trying to set, for example, 0.2 ohms and you accidentally set 0.1, then the difference is you're going from 25 amps up to 50 amps, and that's obviously not going to be a particularly good thing to do to the supply. So I'll turn the output off and we'll go down to 1 ohm, back on, and we're now drawing 5 amps, and we're still getting 5.07 volts coming out of the supply. Showing 5.02 here, but again that's down to the voltage drop in the cables. Okay, so we'll go down now to 0.5 ohm, and I'll turn the load off. Okay, so we're drawing just under 10 amps and we're seeing 5.06 volts coming out of the supply. Okay, so we'll go down to 0.2 ohms. I'll turn the load off first. So we're now at 0.2 ohms. Turn it back on, and we're now seeing 24 amps. The output on the 5 volt rail is now 5.02 volts. So it has dropped by around 0.06 volts, about 60 millivolts, but that's extremely good considering the fact we've gone from very light load and we're now drawing 24 amps. We're seeing 4.8 volts on the electronic load, but of course that's just the voltage drop across these leads. Again, I'll get the thermal camera and we'll have a look and make sure nothing's getting hot that shouldn't be. So we can see that the cables are getting a bit on the warm side. Some of the terminals are getting quite warm. It's one of the problems with crimp terminals. They do tend to corrode over time, and you will find that the resistance of the connection starts to increase. I can't really feel any warmth with my finger, but you can see it on the thermal camera, and that's just the nature of crimp terminals. The heat we're seeing down here is obviously the resistance of the connectors causing some heating. This board is still cold because it's not really doing anything. It's running, but it's idle. It's not providing any current. Transformer, of course, is cold. In the corner there, the two red heat sources are the two rectifier diodes for the 5 volt supply. But everything else seems fine. There's nothing getting hot that should be staying cold. It's looking fine. So what I'll do now is I'll reconnect the fan, and then I'll run this supply at this load for maybe an hour or 2 hours. If anything interesting happens, then I'll add that to the video. If not, then the next step is to do this same test with all the other rails. Again, if anything interesting happens, I'll show that. Otherwise, what I'll do is once I get 2 more electronic loads, I will show a full load test using all 3 loads, and that test will generally run for 3 or 4 hours just to make sure that the supply is properly stable. And assuming all is well, then that will be it for the supply, and it's ready to actually use. So the next step will be to make up a test jig, but as I say, I'll get through this first, make sure all the supplies are within spec, and we'll go from there. If you want me to look at something in more detail, then let me know.